Okay, this is the first recorded lecture of this class. This lecture might be a little longer than usual because we're going to go through some of the main components of the MATLAB as a programming language. Yeah, like the variables, data types, and operators. Yeah, um, I actually opened the MATLAB here so that I can actually do some little bit of demo during the lecture. Okay. Okay. The first thing I want to know is that every variable in MATLAB is an array. Okay, a scalar is just an array of size 1 by 1 with one single row and a single column. Okay, yeah. So basically, each array has at least two dimensions that represent rows and columns. Yeah, and definitely they can have more dimensions, more than two. Okay, yeah. A dimension that has a size of 1 is called a singleton dimension. Okay, yeah. So a vector is an array with at most one non-singleton dimension. Yeah. Um, there are arrays that are normal arrays where each array element is just a single value. Yeah. There are other types of arrays in MATLAB um, where each element can be another array. Yeah, but this will be discussed later, not in today's lecture. Yeah. So we're going to start to create some arrays here. Yeah. This is a command window, and I'm going to create a new array here. Okay. Okay. So this is the list initialization of an array with the name of A. Okay. Yeah, I click enter. This is what you get. This array has 2 rows and 3 columns. Okay. Yeah, the brackets are used for the array list initialization. The semicolon is used to separate rows. So 1, 2, 3 is one row, 4, 5, 6 is another row. Okay, yeah. An empty array is specified like this. Okay. That's an empty array. Yeah. Um, Once an array is created, you can see it in the workspace. As we mentioned last time, this is called the global scope or the interactive scope of MATLAB, where everything you do within the command window, if you create variables, they're stored in this scope. Yeah. And this can be accessed interactively, like those. So we already have that A here. If I click this, this will actually open something that looks like a spreadsheet, yeah, where you can actually edit the elements of this array. Right? Yeah. Well, now we're not going to worry too much about this part. If you have the need, you can do that. Okay, so I can create others. Okay, like okay, yeah, that's another array. Okay, this is a vector, yeah, because it has only one non-singleton dimension. The clear statement can be used to remove a variable from your current scope. Yeah, like if I do this, you can see that B disappears. It's no longer there. Okay. Okay. Array elements, of course, have the data types. Okay. Each array has for a normal array, all the elements are of the same data type. Okay. And there are some predefined data types, the numerical ones, from double, single, that's 8 bytes, 4 bytes, and all different sizes of signed and unsigned integers. Okay. Yeah. there are others like complex numbers or logical type, means the values are true or false. And there's also the correct type, character type. Okay, this is treated differently from the INT8. Okay, so it's not like C. Okay, something that comes with difference is that the data types in MATLAB are all classes. Okay. Yeah, these are not like in C where you have the built-in data types. Yeah, okay, these are not built-in. So for the double, that's a class double. For single, that's class single. Okay, yeah. So sometimes some operations you might find that's strange that it won't work. Yeah, because these are classes. Yeah, and you have to think of them this way. So character is actually of class character. It's different from that INT8 or UINT8 as you do with C. Yeah. Well, anyway, although these are classes, they are predefined. Okay, MATLAB already provides them. Yeah, and of course they are also advanced, and you can define your own data type, including classes. Okay, in the second part of the semester, we're going to talk about how to define your own class. Okay, yeah. So this is a function that you can use to check whether a variable is to see what class it is. Okay, yeah. So because we have not defined classes for the when we declare this variable, like when we do this, we do not specify a class. Then the default class is double. Okay. Of course, you can do the conversion of it. Okay, like yeah. So that's right now the class of A2 is INT8. Okay, the class of A is double. Okay, yeah. So the conversion you have to do specifically. Yeah. Sometimes for scalar, for operators that involve scalar, just scalar. Yeah, so some of the numerical conversions can be done automatically. Yeah, but if not for scalar, usually you have to do this explicit type conversion. Okay. Another function which you're going to see a lot is a function of type is something. Okay. Yeah, there are many of them, and a function of this name will give you a result of true or false. Okay. Yeah. So this is called is a. Okay. So yeah, it's a. So A is a double. Okay. A2 is not a double. Okay. It's used this way. Yeah. For allocation and initialization of the arrays, um, well, we have done this kind of just simple this initialization. Yeah. But a lot of times you just have to allocate some array of some size. Okay. So the basic ones, there are the zeros and ones which you can use to allocate arrays of your desired size. Okay. Yeah. That's an identity matrix. Okay. I'll just give you an example here, like this. Yeah, you know what that is? Okay. 0 and 1s are used for numerical arrays. True and false, of course, are used for allocating logical arrays. Okay. RNAD is a random number generator, each time with an array. Yeah. Let me generate some random arrays. Okay. The size are defined like this. Okay, that's the first dimension, which is the rows. That's the second dimension, that's the columns. Okay, so it looks like this. Okay. The random number generator in MATLAB gives you uniform random numbers between 0 and 1. Yeah, you can always specify your desired size and maybe desired data types for 0 and 1s. Yeah, because there are many numerical data types, so you can choose what you want. Okay, I let's see. Okay, I can say I want like this. Okay, so you can use this string to, that's the class name of the data type you want. Okay, yeah. If you do not specify it, then it's a double. Yeah, as we have said, that's default. And of course, actually you can generate something that's more than 2 dimensions. Okay, like here, this will be a 3-dimensional array. Okay, the third dimension is this, like this. Okay, so only for the first 2 dimensions. Okay. Yeah, some functions for array properties. Okay, like size. Size will give you the dimension of each, the size of each dimension. Like the z we just generate here, size of z, that's 2, 3, 2. Okay, that's the first, second, and third dimensions, the size. And length will just give you uh, the largest dimension. Okay, so this will be 3. That's the largest. And the number of elements, yeah, that's 12. Okay, so it's the product of that. Okay, is empty is a logical function to tell you whether the array is empty. An empty array has 0 number of elements. Okay. Yeah. In addition to this, you can also use um, uh, generate evenly spaced values for initializing array. The syntax is like this. Okay. See the there's a column here. Okay, let's say that's x. Okay, so this will give you a vector. That's 1, 2, 3. Okay, so you can do like this, and you can do like this. The middle one, that's the step size if you actually specify it. Okay, so the 579, you will not go over the last one. Okay, yeah. The last function, that's called the linear spacing. So it will evenly distribute. It will generate evenly spaced numbers. Okay, yeah. So like let's say from 5 to 10, and let's say we want 3 numbers. Okay, I think it's easy to catch what this do. Okay. Yeah. With arrays, of course, a very important thing is about indexing, and this is something you have to be careful about. The first thing to know, we have mentioned last time that MATLAB is derived from the very old mathematics programming language called Fortran. Okay, so there's a lot of legacy features. Because some of those are just different from what most modern programming languages do, like C or Python. So you need to be careful about their difference. Otherwise, you will have a lot of problems. Okay. Yeah, the first thing to remember is that array indices are one-based. Okay, the first element comes with index 1 instead of 0. Okay. Of course, this comes from Fortran. Yeah. So, remember we have that x. Okay, or let's say x is 579. So to index, that's the first element of x, that will be 5. That's the second element of x, that will be 7. Okay. Yeah. The order of indices, row, column, and yeah, you can have other dimensions. The first index is always for the row, second index for the column. Okay. Yeah. Okay. Um, let's say for each dimension specify vector. Yeah, this is usually, let's do something. Let's bring out a here. Okay. Yeah. Let's first try this. That's a simple one. Row 1 and column 2, which will be this. Okay. Row 2 and column 1 will be this. Okay. You can use this syntax to get your subarrays. Okay. Like row 2 and column 1 and 2. Okay. That's a vector. Okay. So this will give you this. Okay. Row 2, column 1 and 2. Yeah. So you can use the vector to do the indexing. This is okay. 1 and 3. You will get 4, 6. Okay. Yeah. Sometimes you can use a column for indexing a dimension. That means you want everything along that dimension. Okay. So this like in this case, it means all rows. Okay. Columns 1 and 3, but all rows. That will give you the subarray like this. Okay. Yeah. There's a special use of the keyword "and" in this indexing, which means the "and", the less, like here, the "and" means less column. Right? Yeah, sometimes it's very convenient if you don't want to specifically specify the size of array. For example, if it's in the function, so you don't know the uh, well, you can get, but this is convenient. Okay. So for this one, that's the same because the size is 3. Okay. If I do like this, that will be the last row, which the row 2, and columns 1 and well, rows columns 3. Yeah. So it will be those two. Okay. Now let's copy this here. Okay. To specify elements or subarrays with different dimensions specified separately, like this, or you can have some index for first dimension, some index for second dimension, and of course you can have more if you have more dimensions. Okay, those are usually, or we should call them subscripts. Okay, subscripts are used for each dimension separately. Okay. A somewhat different indexing, which we are going to call the linear index, okay, correspond to the way the array elements are arranged in the memory. And of course, when they're arranged in the memory, well, they're linear, yeah, because you just have one memory space following another, like that. Okay, it does not look like an array in memory. So with this, regardless of the size of the array, if you provide just one number for the indexing, this will extract as a linear index or treated as a linear index, which means like here is the first element in the array in the memory. Okay, so that will be 15, of course. More interesting, let's try the third one. Third one will be 23. Yeah. So to understand this, we need to know how the array elements are arranged in memory. Okay. In MATLAB, again, Fortran legacy, the indexing is column major, uh, while in C you have row major. Okay, yeah. Row major means that um, because regardless it's MATLAB or C, the first dimension is row, the second dimension is the column. Right? So this means that which one is the major index? Major index means I think you should know what that means. Okay, because that means which one you change first. Okay, yeah. Usually for an array like this, if it's stored in C, it will go like 15, 23, 8, and then 7, 11, 14. Okay, so rows are major. Okay, so they're changed less frequently. Columns are the minor minor dimension here. Okay, so 15, 23, 8, 7, 11, 14, like that. Okay, yeah. So the index dimensions put in front. Okay, like the row here is the major dimension. Okay, in MATLAB, dimensions in front is the minor one. Okay, so it will go like this: 15, 7, 23, 11, 8, 14. That's how it works. So that's the arrangement of those elements in the array. Okay, and the ordering of that is called the linear index. Okay. Yeah. So this is when remember this occur when you only have one dimension showing here. Okay, if you have two dimensions, then those will be treated just like a subscript. Okay, those will be subscript. Okay, row and column. Yeah, but if you just provide something like this, that's linear index. Okay, the fourth one that will be 11. Okay, and you can do things like this. This will give you the whole array regardless of the original number of dimensions. You will return the whole array as a as a column vector. Okay, yeah. So this will allow you to see everything in the correct order in the memory. Yeah, and you can do something like this. That's a single dimension. Okay, so those are linear index. You'll get a 2, 7, 23. Okay. Yeah, we have tried this. Okay, this is a very convenient way to convert everything into a column vector. Yeah. Column vector look like this. Sometimes for computations, it's something convenient and sometimes good practice to make sure all your vectors are along the same directions. The reason is that usually for MATLAB, the default vectors are row vectors, yeah, because it looks more straightforward or more intuitive. Okay, yeah, like when I just said that's a vector, and that's a this one that's a row vector. Okay, yeah, yeah. But some of the operation will return column vector, some will, by the default row vector. So when doing the mathematics operations on those, sometimes you might have some problems. Okay, so for this reason, it's always convenient and good practice to use a form like this to make sure that they are all of the same type of vectors. Okay. These two functions allow you to convert between subscripts and linear indices. Okay, yeah, I'm not going to get into those. And there are the functions that change shapes without changing the memory. Okay, so what they happen is you change something in the header, but the memory, something inside the memory arrangement of the actual values stay the same. I will just use this A as an example. Okay, okay. From here you can see the what's in the memory. Okay, because those are linear index. Now I change the shape of A into 3 rows and 2 columns. Okay. Well, for reshape to work correctly, you need the result to have the same size, the same number of elements as the original. Okay. Yeah. So this also have 3 elements, 3 columns, but 3 rows and 2 columns. Okay. Oh, I forget to assign it to something. Okay, let's do that's A2. Okay, yeah. And let's look at the memory arrangement. The same, okay, the same as this one. Okay. Squeeze is used to remove singleton dimensions. Okay, and reshape just allow you to change the shape or the size. Not exact number of elements, but you may move the size along different dimensions without changing the actual number of elements. Okay. Now, another is a pretty powerful indexing um, of this format where A and B are both arrays. I will again use that A, okay, and I will create something like this. Okay, this is my index array, and let's see what happens. See, this is not a scalar, this is not a collection of indexes along different dimensions. Okay, this is directly an array, but this has to be as integers. Okay, although it's of type double, but the actual values have to be integers. And let's see what happens. Okay, the returned array, you get a separate of this. It is based on what? It has the same size as k, and each element comes from the corresponding element in A according to this as the linear index. Okay, so for the 1 you get 15, which is the first element in A here. For 3 you get 23. Okay, for 2 you get 7. Okay, for 4 you get 11. Okay, yeah. This indexing is actually pretty convenient. Sometimes when you are doing some transform of or some kind of mapping for the arrays. Okay. Let's continue. Once you have an array, how do you modify it? Okay, um, like we can add rows or columns or deleting rows and columns. Okay, let me use the original A as an example. Okay, yeah, if I want to add a column to A, okay, um, concatenation along column dimensions. Okay, let's do this. Uh, Maybe I'll just do this first. Yeah, so you can see this kind of concatenation. Okay, yeah, there's nothing in between here, just a white space. Okay, yeah. Of course, this too has to be the same number of rows, otherwise you get an error. Okay, to concatenate along the other direction, okay, along the columns, or concatenate vertically, then you can use a semicolon. Remember, semicolon separate rows, so they will come in separate different rows like this. Okay. Yeah. Well, processing rows and columns this way is very convenient, but because you're always changing the size of the array, so yeah, internally some allocation and the moving of data have to occur. It's not very efficient. So usually, whenever possible, pre-allocate the space for your data instead of this kind of incremental growing. Okay, yeah, it's not a very good practice for efficiency. Of course, if you do this very few times and not with a very large array, you might not feel it. Yeah, but it's still just not an efficient practice. For deleting rows or columns, you can just assign one of the row or one of the column to uh, empty array. Let me press this into another variable. Okay, yeah, just like if I want to remove the second row, this is the second row. Okay, I can do the assignment to this, which for this it just means to remove the second row. So it's like this. We have for concatenation, we already demonstrated how to concatenate along columns and rows. For the other dimensions, you can use the function cat. Okay. Yeah. Something interesting is that you can do the repeat, that called repeat matrix, which allow you to duplicate. Yeah. I will just play with this. This means repeat f 3 times along the row direction, first dimension, 2 times along the other direction. Just repeat it, replicate. I should say replicate it. So this is what you're going to get. Next topic, text output. Okay. Yes. Well, you already see a lot of interactive text output already. Okay, this is the standard way. Wherever you assign something to a variable, that variable is feedback or echoed back to you with the variable name and of course its content. Yeah, if the content is too large, of course, well, MATLAB will try to show the whole thing. So don't ever try to do this with a large array. Okay. Yeah. But anyway, that's the standard way. Yeah. This takes a lot of space on your command window, so a little bit more compact is used the DISP. Yeah, like this. Okay, so this is F. If you do this, yeah, you can skip the variable name. Okay, a little more compact. Something to remember is for the particular variable name called ANS. Okay, wherever you create or compute some value, evaluate some expression without assigning it to your own variable name, then it will be assigned to a particular variable called ANS. Okay, yeah, so it's always here. I never define this, but it's the result of every evaluation that does not go into a variable name. Okay, so if I do something like this, okay, yeah, you see that's a variable name, value 3. If you don't want to see the result, that echoed feedback, use semicolon at the end of the expression. Okay. Of course, if you're working interactively, you want to see the result. So this is, if you're running a program, a script, or a program, then usually you will use the semicolons because you don't want to see everything just continue to print out on your command window. Now, these are standard text output for just the value of a variable. Okay. Yeah. If you want to create formatted output, the standard way is to use the function fprintf. Okay. This is just like the C function fprintf. Yeah, but it does not have separate function for printf and fprintf because everything, yeah, is still to a file. So this is the same function used for text output to files and text output to your command window. The only difference is that if your command window, you don't give a file specifier or file ID. Okay, you just give it, so it will be treated just like the printf in C. Okay. And for that kind of specification, that kind of format string, is the same way as C. Okay, so let me copy this. Yeah, you already see the result. Okay, 2 by 3. Size of A, as we remember what A is. That's A. The size of A. 2 rows, 3 columns. So that's what that is. Okay. The escape sequences used in C are also usable here. Okay. Yeah. The one difference is that that format string can be reused. Okay. For example, instead of actual size of A, okay, let me just play with this a little bit. Okay. See what happens? Okay. A actually has 6 elements. Okay. There are only 2 format specifiers here. Okay. So those for the first 2 elements, okay, in the order of the memory, so it's 15 and 7. Okay. 15 and 7. So for the first 2 elements, okay. And then the format string is used up already, right? But you have 4 elements in A, so it will be reused. Okay, so this will be repeated until everything in A, all the elements are already printed out. So actually this is quite convenient if you want to do formatted output for a large array, many things. Yeah, you can use a single statement for that. Okay, yeah. The next few pages are about operators. Of course, we have many numbers and the arrays, so we want to do operations. Yeah, most of the operators are just very standard ones. So basically, we'll focus on some of the particular ones that are different, that you have to be careful, which are different in C or uh, compare with C or Python. Okay, yeah. First, the most standard one is that when you're working simply with scalars, then everything is just very standard. Okay, yeah. Plus minus multiplication, division, that's power module. Okay, modules is used as a function like this. Okay, that would be okay. That's the remainder, of course. And you have the relational operators. Okay, this is used for negation. Okay, so this is an equal instead of the exclamation mark used in other language. This was used in MATLAB. Okay, so itself, this is logical negation. Okay, and there are those. Well, there is no bit field here. Don't confuse with C. This is logical AND, logical OR, logical OR. Okay. There is some difference. If you are doing scalar and scalar, this is preferred. Okay. Because they have the same properties as in C. Yeah, that property is that they are short circuit operators. If you don't know what that is, yeah, check that out. Yeah. Yeah, but it's more efficient when you have a lot of logical operations sequenced together. Um, for this, these are the original logical operators used in MATLAB, but they are designed for arrays. Okay, yeah, those two are specifically used for scalars. This because they are element-wise for arrays, so they actually do not have the property of short circuit. So this page is very standard. Let's see when the operation is between an array, of course, a non-scalar array and a scalar. Yeah, those are the standard ones. Yeah, element operations. This one is a little bit different. Okay, module the same. We'll mention this. That's because the power of meaning. There are two different meanings of powers. Okay, and let's create a square array like like this to demonstrate this. Okay. Usually, you see there's the period and that head. Okay, that's this. When you see this period before an operator, that this whole operator usually means element-wise operation. Okay. So you get the cubic of each element separately. Okay. Now, if you do this, well, if you don't know what that is, let's just do the matrix multiplication. Okay, so it's the power of the whole matrix. Okay. So those are different. Remember, with that period, that means element-wise. Okay. Yeah. So those are the major differences. Most of the other like these operators, basically they give you the result in an array that has the same size as the array. Okay. Yeah. When you have scalar operator array, okay, those two are a little bit different because this array in front scalar the second operand. Those are reversed order. For most numerical operators, that's still an element-wise operations, and we're not going to talk about difference. Okay, this, um, okay, yeah, let's do this so that you can see what happens. Remember, S is 1, 2, 3, 4. Yeah, okay. This is element-wise division. Um, the division, if you divide the basic division operator can only be used when the divisor is, which is the second operand, is a scalar. Whenever the second operand is not a scalar, you have to use this to do element-wise. Okay, because when it's not a scalar, it should be treated as a matrix, and this will be matrix division. Okay, so yeah, there you have a constraint on size. Okay, that's element-wise division. Okay. Now the array to array operator. Okay. For most of them, it's assumed that the two arrays have to be the same size so that you can do element-wise operations. Okay, that's so addition and division. That's element-wise multiplication. Yeah, you see the period. Okay, element-wise division, element-wise power. Okay, yeah. Something interesting in later versions of MATLAB is the use of broadcasting. Okay. Size broadcasting means it will try to repeat the size. Let's do something. Okay, some example. For example, A is this size, S is this size. You can, sorry. Uh-oh, I override A already. Okay, I'll use this. Okay. You can see there are different sizes, so this will not work. Yeah, element-wise operations require you to have the same size for both arrays. Yeah. However, in some cases, if the dimension can be replicated or broadcasted, okay, that called size broadcasting, um, then this can actually work. Okay, for example, this is A2. Okay, let's try to do this. Oh, sorry, typo. So what happens? Okay, although they have different size, but A2 can be replicated to the same size as S. So it's 7, 8. It will become 7, 8, 7, 8, and then edit with S. Okay, so that's size broadcasting. Yeah. Sometimes you have to be careful for this. Um, for example, I've used A3 and A2. Okay, those are two vectors, but one is row vector, one is column vector. But if you don't know that, you might just want to do element-wise addition of two vectors. So you might expect something that's A and 10 as a result of this. But this is what you're going to get because both are broadcasted. Yeah, this is sometimes unexpected behavior. Yeah, because somehow you might want to assume that they are the same. Okay, two element vector. Yeah. So a more safe way is to do this. Okay, this does not add much computation. Okay, because this thing only change the header. Okay, only change the header. Yeah. So this is the result that more like for you to expect. Yeah. The next few slides I just quickly introduce some of the math functions. Of course, there are a lot more than this. Yeah, these are just some basic ones. They are the rounding functions. Okay. The result still have the same type as the input. Okay, even though the result are integers in value, but data types are still. If you take double, then the result is double. And all of this can take arrays. Okay, they work on arrays and return arrays. Okay, absolute value, exponent, and log. That's the natural log, base 2 log, base 10 log, all the triangular functions, hyperbola functions. Okay, and for the triangular functions, those takes radian, inputs in radian. Okay, if you want input in degrees, then attach that lowercase d at the end of the function like this. Okay. This is a predefined variable. Okay, of course that's pi. Yeah. So these are, although they work on arrays, but it's applied to each element separately. Okay, there are functions that take on vectors. Okay, yeah, some of them are very easy to enter, like sum and mean and median. Okay, that's cumulative sum and cumulative product. I'll show a few examples. Okay, let me use a vector. Okay, yeah, this is a vector. Okay, that's the meaning of the vector. Easy. Okay, sum of the vector. That's a cumulative sum. Okay, so the first is 7, the second is 7 plus 8, the third is 7 plus 8 plus 10. So yeah, that's how it works. Similarly for cumulative product, right? Yeah. There are functions of min and max. These two functions are a little bit tricky because they have two different interpretations. One for vector, these are vectors, so for vector it's okay. Okay, if that's just vector, it's okay. I'll talk about the difference when we get to the multi-dimensional arrays. Yeah. For this function, if you work on arrays, okay, like this. Let's try this first. These are vector operators, so basically they have to work along one of the dimensions. If you don't specify any dimension, it's the default first dimension, which is along the row direction, so it's the sum like this. If you want to do it in another dimension, okay, like the column dimension, then you have to specify the dimension a bit. If you want to do it for the whole array, then do this. Yeah. So many of the vector operators come with an option for you to specify a dimension. Okay. The tricky part is about that max or min. Okay, remember this? Okay, let's do this. This is not the dimension, but it will be treated as a value to be taken to do make element wise. Of course, It's element-wise, but it's a scalar, so it's broadcasted to the same size as A, and to element-wise. Okay, yeah. So that's not a dimension. If you do this, that's the dimension along the row. Okay. However, how do I specify the dimension along the other direction? Yeah, so you have to add a dummy input. Okay, this has no effect except for making the dimension the third input argument instead of the second. That will give you the max along the current direction, current dimension. Yeah. Sorting is easy. Usually it's small to large. Okay. You can get the sorted. Let's create something that we can sort. Okay. To be more interesting, let's do this. Okay. We probably don't need that large. Okay, just that's enough. Okay. Yeah. You can sort G, that's small to large. If you want the other direction, yeah. Yeah, this is a lot of things work in MATLAB using this directly plain text as to specify the some of the options. Okay. Yeah. Then the other way around. Okay. Yeah. To get a sorted index, I hope you know what sorted index is. Okay. That tells you where in the original array each element in the sorted list vector come from. Okay. So that 4 comes from the fourth element, of course. That 66 comes from the third element in the G. Okay, 79 comes from the first element. Okay, so that's a sorted index. Yeah. Finally, sorting is, again, that's a vector operation. So if it's not a vector, let's do something like this. It has to be work along some directions. Like if you don't specify a dimension, it go along the row dimension. If you want the column dimension, okay, each column itself is sorted like that. Any and all are two functions for logical vectors. Okay, yeah. You say any, of course, that is the OR of all the elements. Logical OR. OR, of course, that's logical AND. A little bit more for today because there are all these things. Okay. Logical indexing is indexing with logical values. Basically, you use an array, that's a logical array of the same size of another array, and to return the elements that for that's has a corresponding logical array element to be true. Okay, let's just use this G. Okay. Let's create a logical element. Let's call H. Logical array. Okay. Like this. Yeah, so it has the same size as the original array. Some of them are true, some of them are false. Okay, and I can just extract the elements where h is true. Okay, so those are all the elements that's larger than 50. Okay. That's called the logical index. Yeah, this will not come out as an array of as the original size because it's just a subset of elements that do not have a particular array shape. Okay, so what you get is just a column vector. Yeah, we can do some interesting operations like let me take the negation. Yeah, so something like this will allow you to do operations on elements based on some logical flag. Yeah, very fast. You don't need to write a loop with a lot of if. Okay, if something do something. Yeah, all those elements that are larger than 50 are already negated. Okay, yeah. Find is a function um, that gives you index. Okay, find actually takes an array, a logical array, and give you the linear index of the true elements. Okay, so if we look at that edge, okay, this is what you're going to get. Those are the true elements. 1, 2, 3, 4, that's 6, 8, yeah, something like that. Okay. Generally, you get linear index, but if you want to get the subscript, you can do this. Okay, then you're going to get the subscripts, the row and column corresponding ones of those. Okay. Yeah. For the matrix operations, I'm not going to use this in the first lab, so I will skip these 2 pages for these few pages for today, and just quickly cover the last slide used for today. Um, well, basically, for the first lab, you can probably do everything interactively. Yeah. But the problem of doing things interactively is that it's hard to track what you have done, and um, more difficult to repeat something you just did because like you're continuously modifying some variables. So um, it's a better way that when you have done those things, you put them into scripts. Okay, like this. Here is something you can, don't worry about some of the other file names I use. Okay, yeah, this is something you can place a script in there, like if I type something here, this will not be executed. Okay, that's a simple program. Okay, I have to save it, uh, give it a name so that I can actually run it. Okay, yeah, you're going to see it here, and then click on that run. It's going to, oh, I think I guess I clicked it twice. Okay, then you're going to get the result. Yeah, that's the result running that script, or you can type the name here. Yeah. So that way you can keep everything wrote in that script file and use at the end to do the demo. Script files can have comments. Okay, so those are comments. Okay. Yeah. Another thing, just when you're writing programs, uh, sometimes if you have really long lines, okay, yeah, because in MATLAB each line is processed separately. So sometimes if you have something really long lines, the program will be difficult to read. So the that is called line continuation. This will be treated as the same line. Okay, let me save it and run it. Okay, just quickly a few tricks. Something to remember is that when you are running scripts, it shares the same scope with your command window. Yeah, so if I want to see what B is, this is what you have. The scope is shared. Okay, something just for you to remember. Then at the end, if I want to clear the things, yeah, I have already accumulated a lot of variables. Many of them I'm not going to use. So you can do this. This will clear out all the variables, and actually sometimes the other resources like file identifier or those kind of things, they will all be closed, cleared like this, and it's for variables. Okay, and for the command window, you can do the clear screen. Okay, that is. Okay, then forget about it. It's not important. I will see you next time. Okay. Oh, it's this. Okay. Yeah. Clear the command window. Okay. So that's for today's recorded lectures.